we're going to graph sine. Okay? And so this will be like the sine value, and this will be like theta. Okay? So we'll say sine of theta, and this will be theta. So what I'm going to do is I'm going to start here at this point, and then I'm just going to slowly swing around to the various points on the unit circle, okay? And then we'll graph it and see what we come up with. So, right here at pi over 2, well, first of all, to go one complete circle around, what is that in radian measurement? 2 pi, right? So I'm going to do one whole circle from 0 to 2 pi. And so this would be pi, and right here would be pi over 4, and right here would be 3 pi over 4. Okay? And so at pi over 4, let's start with pi over 2. At this point here, sine, remember we have 0, 1 on the unit circle. We have, or no, I'm sorry, this is 1, 0. Here we have 0, 1. Here we have -1, 0. And then lastly, here we have 0, -1. Now we said that this is always written in the term of cosine, sine, right? Does that make sense? So now, at this point here, when this is 0 radians, right? I'm going to end up with a value of 0, right? So let me try to draw this out a little bit. This point right here is theta, sine of theta. Okay? Which is 0, 0. Does that make sense to you guys? Probably not, but it will. So now at at pi over 2, at pi over 2, why did I write 1/4? It should be pi over 2. This should be pi over 2. And then this one over here should be 3 pi over 2. At pi over 2, then we have the point right here. So if it's theta, sine of theta, in other words, I'm traveling from here to here. That's my theta of pi over 2, which gets me to here. But then I'm looking for sine of theta, which is 1. So this is technically pi over 2, 1. So what I'm doing is I'm using the unit circle, which has a bunch of information on it, and I'm comparing theta with regards to the ratio of the opposite over the hypotenuse. So if I continue to spin around from this angle all the way down to here, that's a theta of pi. Okay? So at pi, I get a y value or a sine of theta value of 0. So when theta is pi, or just pi, not pi over 2, just pi, whoops, wrong color. then that's 0. Now, if I were to draw and start at 0 and come all the way around where theta is equal to 3 pi over 2, then my corresponding sine of theta value is -1, which would fall right here. At 3 pi over 2, comma, -1. That occurs right here at 3 pi over 2. Lastly, I gotta choose a different color, but one that you guys can see way in the back. If I start at 0 and I come all the way around and make a full revolution of 2 pi radians, then my corresponding y value is 0 again. So this would be 2 pi, comma, 0. And then from that point on, we're stuck on the circle. From that point on, the sine values just keep repeating themselves. So if I were to graph sine, what it looks like is this. It looks like it goes from this point to this point, and that's our function of sine. And then from there on, it just repeats itself. So if I were to graph this on a graphing calculator, and I said sine of x, and I wanted to make sure that I'm in radian mode, and I'm going to set my window up a specific way. I'm going to let my x value go from 0 to 2 pi. And I'm going to let my y value go from -2 to 2. If I hit graph, this is what I'll get. Okay? That's what we just graphed. That's one full period, one full cycle of sine. However, if I go in the negative direction, in other words, this is all these angles going and rotating this way. But if I were to rotate in the negative direction, guess what? It'll still look the same. If I were to rotate and continue to rotate, the pattern just keeps repeating itself because it's a circular function. So if I were to take my graphing calculator and zoom out, this is what sine of function looks like, and it goes on forever. It's what we call an oscillating function, sinusogenous, or a periodic behavior. So it'll say a lot of things, actually. It'll take a second because the calculator is, I'm recording the video and I'm processing videos in the background. I really need to reboot my computer. But this wave sine thing will just go on and on forever. Let's try graphing that one more time. There you go. Like that. That is the first of the three basic trig functions. So now what I'd like to do is we're going to write down some basic information about the sine function because it's important. So sine of theta as a function of theta, and we'll write this a lot of ways. Sometimes we'll write it as sine of x equals y, which is confusing, kind of. The numerical values are the same, but they're based on x's and y's on a unit circle anyways. So we're going to ignore the second one for a little while. Well, let's talk about the domain. Were there any domain restrictions? in that function. And let me just kind of sketch it here for you on the board, just a rough sketch of what sine of. That's what it looks like. Any domain restrictions? No. So it's all real numbers. What about the range? What do you guys notice? Well, the range goes from -1 to 1. In other words, it'll never get higher than 1, and it'll never go lower than -1. Just the basic sine function. We'll transform it later and stretch it and stuff like that, but just the basic sine function, the range is from -1 to 1. And we can include those values. Now, for sinusogynous or periodic functions or circular functions, they have a lot of names. I'll try to keep mentioning them to you. This has a period of 2 pi. It's just a fancy way of saying that after 2 pi radians, the graph repeats itself. It is it's symmetric across the origin and we talk about that a little bit, but do you guys remember what symmetric across the origin means? What type of function is it? Even or odd? Did we talk about that this year so far? Yeah, so if it's symmetric across the origin, is it even or odd? We all know even, right? Even is symmetric across the y-axis. Then if that one is even, then this is an odd function. I always remember odd like this because odd, origin, they both start with the letter O. That's how I remember. Okay? There's no vertical asymptotes. I guess if you want to call it, they're not horizontal asymptotes, but it is bounded from below and above because of the behavior of the function. Anything else?